All right, welcome. Today, we're going to pull back the curtain on something that's, well, at the very heart of making games in Unity. We're talking about how a simple C# script, just a text file really, transforms into the living, breathing behaviors that make our games actually work. We're going to go from a code blueprint all the way to interactive behavior, step by step. So, have you ever just stopped and looked at a character moving on screen or maybe an enemy attacking and wondered, how in the world does that start as just text in a file? Well, it all begins with a blueprint, a detailed plan for what an object in our game can be, and, more importantly, what it can do.
Okay, so that fundamental blueprint, in the world of C# and Unity, we call that a class. And trust me, everything we build, whether it's our main player character or just a simple spinning coin, it all starts right here with a class.
Let's stick with that house blueprint analogy, because it's a really good one. A class is exactly like that. The blueprint itself isn't a house, right? You can't live in the paper plan, but it has all the crucial information, the data, like how many rooms it has, and the behaviors, like where the doors are and how they open. And the best part is, you can use that one blueprint to build hundreds of identical houses. In programming, we call those houses objects.
Okay, let's get our hands dirty and look at some actual code. This here is a super simple player class. Now at the top, we're defining its data. We've got public string player name and public int player health. That word public is key. It means other parts of our game, other scripts, can see and change these values. The string is just for text and int is for a whole number. Then below that, we have the behaviors. These are defined as methods. You can also think of them as functions. We have attacking and taking damage. These are the actual actions our player object will be able to perform. This is what it can do.
So, we've got our C# blueprint, our class. But how does the Unity game engine actually know what to do with it? How does it get from this text file to something real in our game? Well, that's where the real magic of Unity comes in, components.
Okay, now look closely at a standard Unity script. You'll always see this little colon here, right after your script's name, followed by the word mono behavior. That colon is C#'s way of saying inherits from. And mono behavior, well, that's the special sauce. By inheriting from it, our plain C# class suddenly becomes a Unity component. It's the bridge that connects our code to the entire game engine. This is what gives us access to amazing built-in functions like start, which runs just once when the object first appears, and update, which runs over and over every single frame. That update method, that's basically the heartbeat of your game.
So we just saw inheritance in action with mono behavior. But let's dive a little deeper into that idea, because it's an incredibly powerful tool for making our code way more organized and, honestly, a lot smarter. It's all about creating specialized blueprints based on more general ones.
The core idea behind inheritance is creating what we call an is-a relationship. Think about it like this. A goblin is an enemy. A poodle is a dog. So we can create a general enemy class that has all the stuff that all enemies share, like health, for example. Then we can create a new goblin class that inherits from enemy. Just by doing that, the goblin instantly gets all the enemy stuff for free. We don't have to rewrite it. Then we can focus just on adding the things that make a goblin, a goblin.
And the syntax for this in C# is so simple, but it's incredibly powerful. You have public class, derived class, that's our new, more specific class. Think of it as the child class, our goblin. Then that all-important colon, and then the base class, which is the more general parent class we're inheriting from, our enemy. That single colon does all the heavy lifting. It establishes that is-a relationship and immediately gives the goblin access to all the public goodies from the enemy class.
Let's look at a real-world example. Here's our base enemy class. First, notice it inherits from mono behavior, so Unity knows what it is. Inside we have public int health, pretty straightforward, and then a public method, take damage, which takes an integer amount as an input. Inside that method, the line health minus equals amount is just a shorthand way of saying take the current health and subtract the damage amount from it. This simple script is now a perfect, reusable blueprint for absolutely anything in our game that can be damaged.
And this is where the magic happens. Look at this. This is our entire goblin class. It's almost empty, but just by adding that .enemy part, our goblin class instantly has a health variable, and it already knows how to take damage. We didn't have to write any of that logic again. It's just there. Now we can focus all our energy on the fun stuff, like what makes a goblin unique. Maybe it has a special scurry method or a sneaky attack. It's so much cleaner this way. Okay, inheritance is awesome, but it does have its limits. What happens when two things need to share a capability, but they don't really have an is-a relationship? Like, a player can take damage, and a wooden crate can take damage, but a player is definitely not a type of crate, right? That relationship doesn't make sense. For situations like this, Unity champions a different and honestly a more flexible approach.
And that brings us to composition. Honestly, if you want to understand Unity, you have to understand this. This is its core philosophy. Instead of building things in rigid family trees, we build objects by assembling them from a collection of interchangeable parts. Think of it less like a family tree and more like building with Legos.
So here's the absolute key difference, side by side. Inheritance on the left is all about that is-a relationship. A goblin is an enemy. But composition on the right is about a has-a relationship. A player isn't a physics object, but it has a rigid body component that lets it interact with physics. It's not a health bar, but it has a health component. See the difference? We're just snapping on the abilities we need.
And this component-based approach has some massive benefits. First, flexibility. You want to give an object the ability to fly? You don't have to rewrite its DNA, you just add a flying component. Want to take it away? Just remove it. It also means our code is modular. Each little component does one job and does it well. And the reusability is just incredible. That health component we talked about, you can use the exact same script on your player, on every enemy, on a boss, and even on that breakable crate we mentioned. It's so efficient.
All right, so our game object is like a collection of these specialized little components. But now for the final crucial piece of the puzzle. How do they actually talk to each other? How does our player movement script tell the rigid body component, hey, we need to move left now?
This little chunk of code is the answer. Let's break it down. First, up top, we declare a variable, private rigid body 2D RB2D. This is basically an empty box that's designed to hold a reference, think of it like a shortcut, to a rigid body 2D component. Then, inside the awake function, which by the way runs even before start, we fill that box. The line RB2D equals getComponent rigid body 2D command is one of the most important commands in Unity. It tells the script, look on the same game object that you are attached to. Find the component called rigidbody2D and stick a reference to it in my RB2D variable. Once that line runs, our RB2D variable is no longer empty. It's our direct line to the physics component, and we can use it to do things like control the player's movement.
So really, the whole process of getting scripts to talk to each other boils down to these three simple steps. Step 1, you get a reference to the game object that has the script you want to talk to. Step 2, you use getComponent to grab the specific component on that object. And step 3, once you have it, you can call its public functions or mess with its public variables to make things happen. It's basically find, grab, and use. That's it.
So, there you have it. We've gone all the way from a basic C# class blueprint to two really powerful ways to structure our game's logic. You've got inheritance, which is perfect for creating those strict is-a relationships. A boss is a special type of enemy. And then you have composition, which is really the Unity way of doing things, building flexible game objects that have a collection of abilities. So the next time you sit down to code a new feature, I want you to ask yourself this one simple question. Does this new thing need to be a type of something else, or does it just need to have an ability? Getting that right is the absolute key to writing clean, powerful, and truly flexible code in Unity.